Hey guys, Mr. Brad back here to talk about the second physics talk. I'm probably going to go through this one a lot quicker than the last one simply because it's covering a lot of the same concepts. The first part here just talks about Newton's first law of motion. And as you guys know, it's also called the law of inertia. And it's just kind of describing here that there's actually three parts, even though it's like the most simple of Newton's three laws of motion. Pretty much just says, like I've talked about, okay, objects at rest stay at rest. They are very lazy, and objects in motion stay in motion, and they will just continue at the same velocity forever and ever unless something else actually acts on them. And that's the third part, is that there can't, if there is no force, then all objects will just keep on doing whatever they're doing. So it says here, oh, no change in motion. So they keep doing whatever the heck they're doing. So again, to give you an example here, and it was a lot like the example that I gave to you guys in the last lecture of pretty much if you are holding something and it is staying still, the net force is 0, okay? But let's say if you push up against gravity with a greater force than gravity, then now Newton's second law comes into play, and that object will begin to accelerate upward because the net force is not 0 anymore. Alright, so 3 collisions in 1 accident. This kind of just goes over a scenario when someone's driving, and goes over how you can actually observe all of Newton's laws just by observing an accident and how many forces there are. And Newton's third law says that for every force there's an equal and opposite force. And just like that, for every action there's an equal and opposite reaction. Alright, and this is a very good example that you're going to have to look over that's really going to help you on the test, because the test is going to ask you, it's actually going to bring up a scenario of some sort that's going to ask you about which of Newton's 3 laws do you observe here, and where do you actually observe them, and why. Okay. Alright, so this part here, this is the part that's really going to help you out with your challenge next week, and in addition to the challenge, it's going to help you out with the test, because there's about 5 questions on the test that are all on pressure, and pressure is the force per unit area. Okay, now again, pressure is pretty much saying that the amount of force in a specific area. And so you can see the little kid here, he has a seatbelt. It's a 5-point harness seatbelt, and it's covering a pretty big area on his body. Alright, and so that means that a great force can be exerted over this large area without there being a whole lot of pressure. Okay, now imagine that this thing was a wire rather than big old straps like this, and if you got an accident, the wire would actually have such a great force that it would cut into the child, or much worse. Okay, so again, here's a good definition that they put here. Force that is spread over a given area is called pressure. Okay, the smaller the area that the force is put on, the greater the pressure. The larger the area the force is put on, the less pressure that there is. Okay, and they bring up this little spring scale pulling this clay figure, and they put a wire on the guy, and so whenever you put any force on this wire, it actually slices right through the clay figure. Alright, now if you made that bigger, it wouldn't slice through the clay figure at such low forces. And here, the Act of Physics Plus, I'm actually going to go into this because you guys are going to have to know how to calculate pressure. Pressure is just super easy because, like I said, it's inversely related to the area and directly related to the force. Okay, so if the area is really large, then the pressure goes down. Okay, if the area is really small, the pressure goes up. If the force goes up, the pressure goes up. If the force goes down, the pressure goes down. Okay, so these again are inversely related, meaning if one goes up the other goes down. Then these are directly related, meaning if one goes up the other goes up. And they give you some sample problems here, and just so you guys can have another example, I'm going to go over this one real quick on how to go through those 4 steps with the same thing. Okay, so again, we use the equation P equals force divided by the area. Okay, so if we're trying to find the pressure, then we need to know what the force is, and we need to know what the acceleration is. Okay, because those are our 2 missing variables in this equation if we're trying to find pressure. So let's first read the sample problem. 2 students have the same mass and apply a constant force on the ground of 450 newtons. Alright, so we found the force. Okay, so they're both doing a force of 450. Now, since they're talking about 2 students, it looks like we're actually going to compare the pressure of 2 different people. So we're going to go ahead and do pressure 1 and pressure 2. So student X is wearing snowshoes that have a base area of 2 meters squared. So here we go. The force divided by the acceleration, if we were to plug those in, pressure equals 450 divided by 2. So the pressure is, for this kid, is 225. And that will be Newton meters squared or pascals. Okay. Then student Y without the snowshoes has a base area of 0.1. So 1/20th that of the first student. So area equals 0.1. Alright, so P2 equals 450 divided by 0.1. And anytime you divide by a decimal, pretty much, if it's 0.1, multiply by 10. Makes it a lot easier. And you get 4,500. So 4,500 pascals or Newton meters squared. So you can see that this number is about 40 times larger, simply because this student had on snowshoes and had a really large area to put his force down on, whereas this student only had shoes and he had a really small area to put the force down on. And it's just kind of giving you the idea of if you're walking out in the snow, and I don't know how many of you have ever walked in really deep snow, but usually you step down and the snow doesn't really hold you up. So what people do is they put on these big old snowshoes, and it increases the area that you're pushing down on the snow. And what that does is then the snow can then hold you up. Okay? That's pretty much all I really want to cover in this lecture, is how to calculate pressure and some of the other things that I've covered. So if you have any questions, make sure that you write them down, and other than that, I will see you guys next time.